Hello everyone. Welcome to the fourth edition of FlameCon. So happy to have you all in this event with us. I will have some exciting talks today. We're going to talk about an awesome game that was developed with Flame, and then we have some awesome talk about from Hannah about some Rive integrations with Flame. And finally, by the end, I will be sharing some good news, some news about our our full release from the V1 version, among all other awesome things. Great. So, without any further ado, let me bring Christian and Alex. Welcome, folks. Awesome to have you with us today.
Thank you. Hello, everyone.
Thank you. We're very
Cool.
happy that you gave us the chance.
Yep.
Awesome. Really looking forward to see what you guys have built with Flame. That game is so much fun. Can't wait to see how it was built, and very excited. All right, so without any more delays, the stage yours.
Okay,
Go ahead with your presentation.
then let me
Yeah.
share the screen.
Let's wait for the presentation. Okay. So welcome everyone to our presentation. Today we want to talk about the game we have made, and we want to tell you how we turned a coffee break idea into a real game using Flame and Flutter. And at first, let us introduce ourselves. Christian?
Yeah. So also welcome from my side again. I'm Christian. I'm the founder of Defo. That's my little side hustle, let's say, and full time I do work as an R&D lead for IDEA, which is a software that does solutions in the maritime industry. Nothing with games, unfortunately. I'm a big fan of Flutter. I'm also into technical writing, and I'm also very interested with when it comes to data handling, analytics, and databases.
And my name is Alex. I work alongside Christian at IDEA as a full stack developer, and generally, besides that, I'm about all things software. I like Rust, I like Flutter quite a lot, and I like to experiment with new technologies and stuff. And I really like game dev, but unfortunately, just like Christian mentioned, there aren't a lot of opportunities to do that nowadays. So first, we want to tell you about Orbit in general. Orbit was developed by us for Interconnected. Interconnected is a company which does mindfulness and meditation apps, and for them, Orbit was an interesting side project. In general, Orbit is a physics-based puzzle game with user-generated levels. It has those basic core gameplay elements. First, you have a physics-based ball, which you launch on the level. This ball needs to collide with all the given targets. And you can use gravity, moving objects, and wormholes or portholes to your advantage to complete those goals. So now let's tell you about how it all started.
So just a quick rundown how we went from what you have seen there and how we get there actually. So that's the first live sign of Orbit that I got via email. That is actually a drawing that was made by Martin, the CEO of Interconnected. I think he was in the mall, so he quickly drew that on a single sheet of paper, and it describes the basic concept of the game, the elements, and some basic interactions and how they work together to actually form a level and what's the goal of the game. From this, our challenge was to find the art style and obviously give it a more bit content behind it. So what we did, we came up with this single sheet, which shows the shows the art style already a bit. So it gives you some very early drawings that we have made. It describes how elements can interact with each other. So, for example, the checkpoints that you've seen in the video before, they are rotating. When the player hits them, they shrink to the back, and the whole thing. So we had to make up a full plan of the game, a proof of concept, and of course, to do this, we had to choose the right tools for the job. Of course, it's Flutter and Flame. That's not a big surprise to you, but I want to quickly mention why we did it. For Flutter, It's simple. We both had collected quite a bit of experience with this. We published apps to both stores for our main job. We are very happy with the experience Flutter gives you from a development side of view. It's easy to create in UI and UX. And the true multi-platform support that Flutter offers is great if it comes to app development, of course. For Flame, we had a given set of features that we needed, and Flame was a perfect fit for this. And also I had a bit of experience up front with Flame because I wrote some articles about it to make a game. I wanted to try it out because game dev is cool. So of course, now we have a plan, we have the tools, but there's always a few challenges and solutions. And that's something Alex wants to talk about here.
Yeah, in this segment, we want to talk about 5 challenges we have encountered during the development of the game and the solutions we have came up to solve them. First, we want to start with how we defined and how we implemented the graphics in our game.
Yes. So what you can see there on the left are a few screenshots out of Orbit that show you nearly all elements in the game. They are all without any sprites. So everything you see there is done via normal, let's say, canvas render methods. It's all basic polygons. And the effects, the visuals, the glow of the inner part of the planet, the white glow, and the outer neon glow is done with blend mode and mask filter. And the size changes and other effects, they are done with transformation matrix. The first thing I would like to show you real quick is how you can achieve the glow or neon effects in Flutter. It's actually quite simple. The only thing you need to do is assign a mask filter to your paint. There's 2 examples that you can see on the left in the code. So you apply it to, like I said, you create a mask filter with blur style. For example, the inner white core of the planet uses the solid style, which achieves a glow to the outside. So that can be used, for example, for light sources or other things. And the second there is the outer glow or outer style, which makes the inner side of the shape transparent and only the outer part of it glows. So that's used for the gravity field of the planet to show that it's like glowing and it's in the space. Besides there are 2 other modes also available. It's normal, which means it's fuzzy inside and outside. That can be used to cast shadows or to make the effect of a casted shadow of an object. And inner, which is fuzzy glowing only in the inside of the shape, which you can put behind something, and with alpha values you can make things like glow from the inside. Beside this actually simple things with the mask filter, we also had to do, let's say, a bit more complex things when it comes to effects that require us scaling, rotating, or in other ways changing polygons in the playing area. So like you can see here on the left shows the effect that is triggered on a collision of a player with an object, with an obstacle in this case. To do this, we use a transformation matrix. There's a class in Flutter, it's called Matrix 4, that offers nearly all of the things you need for this. And in the end, the transforms works like this, that you have to first align the origin or the center of the polygons and then scale each point by time. So as you can see, the thing is glowing, it's rippling out over time. And that's, of course, done by changing the drawing and changing the alpha value to increase the size and later fade it out. That requires a bit of code, and there are some actually very great tutorials that we have linked here. We will later make sure we share the slides so that you can get the actual links. One, just real quick, one shows you how it works in Flutter and directly shows you how the code looks like. And the other one is a really cool interactive demo where you can type in the values and the web page will directly reflect how the points would change if you apply this matrix to your drawings, which makes it really nice and helpful as a tool while you play around with this. Okay, now
Okay, so the next challenge we wanted to tackle is keeping the player experience consistent. What we were trying to achieve is maintaining an 11 by 19 square grid of elements on any screen, keeping player movement consistent and predictable, and also ensuring that all levels, including custom levels, are always playable on all different devices. During development, we encountered that, obviously, as any cross-platform app would encounter that, devices have unpredictable aspect ratios, resolutions, refresh rates, and CPUs have varying levels of performance. So how did we tackle this problem? We decided to implement a couple of custom solutions. At first, we set up an abstract physics environment with predefined constant, well-known values. This means that all the objects which exist in the physical world have constant sizes and masses, which keeps the movement and interactions obviously consistent. Next, we added some translation layers, which translated the physics world coordinates into the screen coordinates, and also the translation layer that translates the inputs from the screen into the physics world. Later, we also added a wrapper coordinate system, which represents physical meter coordinates as grid cells, basically, to make everything simpler. Next point, or challenge, we needed to tackle is game state management. There are a lot of ways to do it. We decided to try it our way because we wanted to achieve modular global state management logic and also ensure that work is spread evenly over multiple frames if necessary. We give it a 10 millisecond window. We do it because mobile devices have a relatively underpowered single-threaded performance. Therefore, we came up with a solution which includes a message queue and 3 types of messages. One of them is a basic one, and 2 of them are child ones. Abstract control message, abstract executable message, and abstract complex message. We are going to talk about them in the next slides. First of all, I want to talk about the general implementation. We have an update loop. This update loop on each update tick runs a loop which processes message queue messages, and it tries to process as many messages as possible until it runs out of time or until there are no messages to process. So first, let's talk about the first type of message. Abstract executable message is a type of message which has actual logic. This logic executes based on the context, which contains a reference to the game and a reference to the state. As you can see, it gets implemented as this very simple method. And executable messages cannot directly produce new children or new messages to the message queue. For this, there is a different type of message. A complex message is a message which outputs new messages based on the context. Whenever it outputs new messages, those messages are put onto the message queue at the same position where the parent was. So you can always predict the execution order. So the child of the complex message which will always go right after the parent.
Beside that, we have our message system to keep things smooth. We also had to think about another way because, for example, in Orbit, it works like this. The levels are not fixed. They can get downloaded from a server in the backend, and there might be hundreds of levels. The reason that we do it like this is that you can push an update to your app without actually updating the app. So we came up and we thought, okay, let's use isolates for this. In general, an isolate is a piece of code that runs on a different thread in Dart. And we made our own tiny little isolate framework. Isolates in general work like this, that you, in our framework, of course, create the isolate object. You pass the reference to the game to it and any other further configuration it might need to complete its job. Then you start it and it starts in a new thread. It does its work and communicates back to the main game loop, the main game thread or the UI thread via a port. So it can send messages. In our case, we support 2 types of messages. It's either a string, then we just lock it into the debug log. It's very nice if you look at it while debugging the app, or it's a control message type. So it's something that we can put on the message queue that Alex has shown you before. Let's have a look at an example in Orbit. So Beside the levels, we also might want to configure, turn off, turn on specific things in the app. So we do have a remote config, a JSON file sitting on the server, and we want to make sure that the game downloads this. So we do spawn the get remote config isolate, which then starts in its own thread and starts creating the HTTP request. So it does make the download of it, prints the current state of the request into the main thread. That gets logged in the debug log. Once it's done with the request, it makes sure that it transforms the JSON into actual objects that we can use in our system, creates messages for this, and puts them via the send port back into the main queue, where the game can then process them in the 10 millisecond time frame that we give it on each iteration, which allows us to work smooth with the game without interrupting or have any frame lags, while still having kind of heavy lifting in the background.
Yeah, the next task we had is the feature we wanted to have in Orbit, sharing custom levels. We wanted those custom levels to be shareable completely offline. Therefore, we needed to fit complete levels into small text codes. So in Orbit, we have two types of codes you can share. First one is just a string of text, which can be shared via a tweet or a text message. And the second one is a QR code, which contains this text code. While looking for solutions for this, first of all, of course, we looked at JSON. And as a secret, we do support JSON under the hood. But unfortunately, it was too verbose to use for actual users. We also looked at other binary formats, but unfortunately, they either weren't efficient enough or they weren't supported by Dart for now. Therefore, we came up with our own tiny custom solution. We introduced a custom bit encoding format. Bit encoding means that every bit matters there. We support a handful of simple data formats. First one, and the most probably important one, is a variable bit-sized integer. It can be from 1 bit to any n number of bits. It's very useful because there we have the most amount of space saving. We support floating point numbers, booleans, and date times. Later, how do you construct and use the encoding? You create a simple bit writer instance, which records all the elements of those types which you want to encode. Then it translates it to a bit array. On top, you can see a package which we use to work with bits without any bit shifting. Later, it translates it into a byte array, and this byte array gets encoded using base 64 and share. On the bottom of the screen, you can see an example of a level code you can share, or you might as well later try to use it. Who knows?
Okay, so beside the, let's say, game dev related challenges that we had, we would also like to give a quick outlook on our view or perspective on monetization systems, because not every project needs to make money, but many projects do. And we collected some experience. The first thing I would like to talk about is using ads. I think most of us can agree that ads are not great, but there can be a valid option to get something back or out of a project. As often, it depends on how you use them. For example, there's a research of Unity that shows that the ad type rewarded video, so you watch a video and you get something for it, is quite accepted nowadays. And that's actually what we took for Orbit. As I said, it's important how to use them. And I think one very, very important thing is that they do not interrupt the game flow. In Orbit, it's like this, that if you're stuck on a level, you can watch an ad and then you get a hint. So the game draws the position where you should start to solve the level. So don't break the game flow, and keep in mind there might be other things that you have to take into consideration, like privacy concerns, so rules and regulations with GDPR. And of course, if you add an external service to your app, it doesn't matter what, you increase the complexity of the app because you depend on another system. Talking about dependencies, so we use Google Mobile Ads for this, which is in the backend AdMob. And to use AdMob, obviously you have to sign up for it. You then have to create your app in there, one by platform, which gives you a unique ID that you have to put in the app, and you have to configure the app, or you have to configure it in your plist and manifest file to actually inform the platforms that you're using an ad network. Once all the configuration is set up, you want to serve ad units. That's what it's called. Ad units, again, have a specific ID, and each ad unit also has a specific type. Like I said, we are using the rewarded videos, but there are other types available, banner ads or native ads. These are things that you can fully customize and fit them into your UI in the way you need them. Important here is that you, while you are debugging and testing, use public ad unit IDs and not your, let's say, productive ad unit IDs. Otherwise, your account will most probably get banned. Also, what we have noticed for iOS, as long as you're in test flight, it looks like you don't get any productive apps shipped. So you will just get no ad. Actually, getting no ad is something that you should handle in your workflow. So loading the ads should be gracefully. If it fails, you have to think about what you want to do. In Orbit, it's like this. If we cannot load an ad, you get a free hint. So beside ads, we have also integrated in-app purchases. My view is there like this. There's these two models. You either pay upfront, so pay once and play, or you have the free to download things. There are a lot of apps out there, and you need to compete in an already very crowded market, and it gets crowded day by day. So you need to convince people, if you go with pay once, to do something upfront before they got the app. And that can be difficult. Also, the market is shifting to a pay later model. So we use this and said, okay, we make a free to download app, which of course gets downloaded more often. So the conversion rate is higher. But also it gives you the opportunity to go for a pay what you want or pay what you think is the right model. So it's a bit more flexible than a price in the App Store. And that's actually what we did in Orbit. So users can decide the price they feel to pay, or even say, no, I take it for free. In-app purchases in general are quite good documented and how it works. So the 95% there is, I made it up. It's just my view. I think it's just the last 5% that are maybe not so obvious. And I hope with the next slide, I can save some people some time, because there's quite a few things involved there. And as I said, there is a good documentation, but use a real device. Yes, you can do it with the emulator for iOS, but use a real device. Make sure that you sign the paid app agreement in the Apple Store. It's a bit hidden and it's an optional thing. Even if you made a developer account, you still have to sign it later. If you don't do it, you cannot even test it. So you need to sign this. For Android, make sure that the build number in your Play track, in the Play Store for your track, which has to be at least alpha track, is the same as in your YAML file for the Flutter project. In general, of course, for both things to test, I would recommend to have the thing in the related test tracks of the stores. Also, for Apple, that you can start testing in-app purchases, you need to create the products upfront, of course, but you also have to provide a screenshot and a description and make sure they're in the ready to submit state. That means you can test them. And you need, of course, tester account for both platforms that are able to license test or sandbox accounts to test things. So in Orbit, that's the screen we have there. It's actually a bit older version, but in general, that's how it works. So you can pick a price out of the lists. The prices are, of course, adjusted automatically from the store backend to fit the currency of the user looking at it. In general, it's recommended to have your own backend to track purchases. That's especially very important if you make a game that has in-app purchases that are consumable. So, for example, a booster item or whatever you can consume. because the store backends do not track this. You have to do this on your own. That's important. Then again, like the ads, it's an external system. It's network requests. So it might not be available all the time. You have to handle this situation again gracefully. So if the store is not available because no network or whatsoever, you have to incorporate that into the flow of the UI and of the app, of course. And then one thing, I still don't understand why they did it like this, but if a purchase is done by your customer, so he has chosen a payment method and it's paid and it's confirmed, your app still has to confirm this. If you don't do this after 3 days, it gets reverted. So keep in mind, confirm the purchases, otherwise they will disappear. That's enough from money and purchasing. Back to game development.
Okay, now back from the commercial things to talk about our future steps we're planning to take. At first, we want to explore ECS, or Entity Component System, in Flame and Flutter, as currently it seems to be becoming an industry standard in game development, and it also offers, obviously, a lot of architectural or maybe performance benefits. Who knows? We need to test it. Also, next, as web obviously dominates our day-to-day lives today, we want to further investigate usage of Flame and Flutter on the web. We want to test performance, we want to test limitations and features of shaders or different masks. And for example, we want to see if we can use web workers to actually properly multi-thread the work done by our tiny isolate framework. Also, we want to improve and expand on our current homebrew solutions. We want to simplify the abstraction layers because the code currently is kind of dirty. We want to extend the message queue, make it more flexible and capable. For example, we very recently added support for async execution there to explore better applications of multi-threading in games on mobile specifically, and to generally clean up things and separate it into small libraries we can reuse later, or someone else can reuse later. And in general, thank you for listening to us, looking at our presentation. You can find us at those social media. Please follow us if you want to hear about our future projects.
Yeah. Again, also thanks for me, but there's just one last thing I want to show you. As Alex has said, you might use your level code. You might do it here. So feel free, give Orbit a try. We made a web version for you, which has the full game, the first few levels, and the whole editor, so you can try it out. One little side note, if you go and make things Flutter web, make sure cache can be a bit of a challenge, and force Flutter into Canvas renderer. We had a very funny evening while it was running in HTML renderer, and everything was kind of special and not usable at all. So with this, we are done. Thanks a lot for your time.
Thank you very much.
Awesome presentation, guys. I really like the part which you show the idea in paper. I love to see how ideas are born. Very, very interesting. I wonder if anybody has any questions to Christian and Alex. If you do, just ask on the chat.
Yeah, we would be glad to respond.
Sure, and I think we will have to make the slides later available because there's some links inside that might be helpful. So I will share it with you, and you can share it then, of course.
Sure. Yeah. Feel free to share it on the YouTube comments, and I will put the description if you have all the links that you send.
Yeah, and I see.
Send the link for the game too, so I can promote it a little bit and people can download it.
Okay, sure.
Also, I see the first message. Any plans on going to the desktop? For now, no official plans, let's say, but it should be possible. There should be any problems there. Though I have to admit, we haven't tested Flame on desktop, either Windows or Linux yet.
Awesome. It would be so cool to play that on desktop as well.
Might be.
I tried it on my Xbox in the new Edge. Yes.
Yeah, in the browser
version.
Okay, so next FlameCon we have a talk about Flame on Xbox, right?
it works until Edge decides to stop working. So
Oh, yeah, I see.
yeah.
Okay.
Okay, I think we don't have any more questions. So thank you so much for your time to put this presentation. It was such
Thank
a
you for
pleasure
having
to
us.
have you. Thank you so much. See you on the next one.
Bye bye.
All right. So super interesting talk about an awesome game made in Flutter. And now I'm gonna bring Renan to the screen. Hey Renan, how are you
Hello
doing
there.
today?
Hello there. I'm doing fine. Can you hear me? All right.
Yeah, yeah, there is some noise, like a ventilator or something in the background, but we
Okay.
can hear you.
How about this now?
Yes, it's a little better. Awesome.
Great.
So today you're gonna talk a little about
Yes.
Rive, right?
Yes. Let's talk about Rive and how to integrate it with Flame. You can have lots of great results when integrating these two things. So yeah, I think I'm already sharing my screen.
Also, I'll bring your screen to the stream and you have the stage.
Okay. Thanks. So yeah, let's talk about integrating Rive and Flame. This is a long overdue subject. Lots of people ask about it. So it's not hard, and we are releasing a package to make things even easier. But yeah, let's go with baby steps. First of all, what we're gonna do today. So let's talk about what's Rive and how to create something that we call a state machine in Rive or an animation, and also how to add this animation, add this state machine to a Flame game, and after that, how to manipulate this animation with code, with everything you have on a programming level. So yeah, first of all, what is Rive? So Rive is this kind of product here that is a way to create animations, not only animations but interactive animations, and also then you can download a file and embed this into any platform. One of them is of course Flutter, and if something runs on Flutter, it of course runs on Flame as well. So what is this state machine? So you can have an animation like this one, and this animation can react to user inserted changes. And this kind of state that we can call can be derived from some kind of some different types of data. In this case here, we have this level kind of variable that we is the type of a number, and if we change that number, the animation reacts to it, and so it's basically a stage. We have 3 levels of skill, and there's the beginner, the immediate, and the expert. So it's pretty cool. But this, of course, wasn't done by me. It was done by someone with lots of talent. I don't have lots of talent on this. So to explain how state machine is done on Rive, I made this one. Which I think it's a little bit simpler. So let me close this here. Okay, so basically we have these circles, right? That I can call, this is a planet, this is a moon, and this is the moon of the moon, basically. So we have something like a state, and I wanted to do something that resembles orbits, just because we just had a talk about a orbit game. So basically we can spin a planet, we can spin and have a translation effect in each level here. So basically I wanted to have this, let me go for this one, moon translation. Yes, this is better to explain. Have this effect, right, of spinning them, but look closely, we are not spinning the objects. The illumination is coming from the same direction, basically. And this happens because we have something called constraints that can make objects follow others, and we have these invisible objects that are most control points than anything else. So for example, we have this Mon translation controller. So it's like an object that is here, is in the center, at the same place as the center of this big circle here of the planet. But it has some kind of a rotation, it accepts a rotation effect. And inside of it, we have another point of control that is translated from this control. So if I rotate this one, I will change the position of this controller. And we have a constraint in the Mon that is a distance constraint that makes the Mon follow the position of this object. So basically, spinning this control point, we change the position of the Mon without rotating it. And since we also have something else, something similar to this one, so we have a control point, another control point here, and inside of it, another control point that makes the minimum follow it. We can have the same effect here. So it's not rotating the objects again, just rotating the controllers and changing their position. This is pretty cool to do some stuff because we can change some aspects of the object without changing a lot of it. And also you have something like this as well. That's another control point that rotates all the planets, that makes the light source kind of thing. So the light source, the idea of light source is the same for all objects. So if I rotate this, I rotate all of them at the same time. So when you have different controls, you can change all of them simultaneously. So how we make a state machine out of this? So basically, we have two things here: state machine and animations, right? This is an animation. This is an animation. So this is pretty much like Flash. For example, you have keyframes and stuff like that. For example, the light source rotation, that is this animation that just basically rotates everything, has two keyframes, right? And the first keyframe, we are rotating this thing at, let's go for the keyframe, at 0 degrees, and after that 306 degrees. So it's basically rotating, rotating, rotating. And in this state machine, that's pretty much like any state machine, is you can create a state, but each state, this is the secret, each state is an animation. So that's why we have some idle animations here that doesn't do anything, because they will be translated as states here. And for now, we have this special kind of state that is a blend between two animations. So here we have a mini Mon initial. So this mini Mon initial basically rotates this thing at 0, and in the end animation it rotates at 720. So it's 2 complete spins. So, and also we have the Mon, which is the same thing, but in this case the end is 360, and we are blending it here to 0 and 100, and these values are coming from this, what we call input. So this is kind of the value that will be set by the runtime, by the user, basically. So if I change this, it should animate. So if I play animation here and change this, it basically will rotate, right? And we have another kind of input, which is a kind of a Boolean input. If I click here and don't click here, so the idea is if it's true, it's spinning. If it's not spinning. So basically, we are running this animation if it's true. We are running this one if it's not true. So basically, what we're doing here, we are creating layers of the state machine. So in the second layer, so it's basically a second state tree. We have this, which is a little bit, it's a little bit more beautiful to see as a state tree. So basically, when we are playing, let's set, so you can visualize the changes here. So if you set to true, we are playing this one. If you set to false, we go to this one, and you can have condition between states. In this case, the condition is the input is true or false. So basically, this is how you can create a state machine on Rive. After that, you can download the file, and there we go. But I'll not be using planets to integrate on Flame, because I already have created another one. This one is a little bit more complex, or should be a little bit more complex. I just started to port this one, but basically we have one control point that controls the skeleton of this entire thing. So basically, if I change a little bit, if I go a little bit overboard, it's weird, but in a range, this is quite cool. So I have a bone, some kind of a skeleton here controlling the bow, and also controlling the arm. Basically, this is the idea. And I create a state machine just like the one we already saw on rotation, that from this input that we call factor goes from, let me play it, I should play, it grows from 0 to 100. So this is basically an idea, and it doesn't let me go overboard because I am using blend between 0 and 100 and min and maximum states, basically. So I defined the range that's comfortable, and that's it, because if we change a lot, weird stuff happens. So we don't want this happening in runtime, right? So yeah, let's put this on a Flame game right now. So what we have here is, let me just change here my tab. Good. So what we have here is a basic boilerplate game. Main, run app, a stateful widget that has in the state a game, right? And I pass this game to game widget. So everything here is available on any Flame game, and what's not Flame here so far is Flutter, basically. And what we have in the game is a load of two sprites, I guess. So it's just images, this one and this one, basically. And I'm loading these two, and after loading, I am adding these components to the game. So all of them are basic sprite components, except this one, which is a position component that only draws a green square somewhere in the screen. So somewhere is the position passed to position component, which in this case is this weird, and I guess I set this like, since it looks a cool place to put a player here, but it's not beautiful. It's just a green thing, and I don't want this green thing. I want the Rive animation just created. So I downloaded it. I put here on assets, sorry, and I can put this to our game using a special kind of component that comes from this package here, Flame Rive, which is recently released, basically. And yeah, let's go. First of all, I'm gonna pass this line of code here, which is an artboard. Basically, when you have a file, you can a Rive file, a Rive project, you can have several artboards, but in most cases you just have one. So load artboards downloads the main one for you. Let me just import here everything. I also have to import Rive, of course, for file, and then we have an artboard. And also I'm going to transform this into a Rive component. What's a Rive component is basically a subclass of position components. So everything we have to pass to position component, we also have to Rive. But we have another required argument, which is an artboard. So basically we can have an artboard here. That it is the thing that we just loaded there, and then we can pass the artboard to the Rive component. Basically, let me make this required just because, and also pass artboard here, Archer artboard. Oops, nope. Wrong case. Good. Okay, I should restart this. Yeah, it will take a while to restart the application, but yeah, let's go a little bit further. We we can also add something that we call a controller. So basically, controller is something that's tied to an artboard, and it will be the thing that will be locating in code the input, which is, let me load here, this value here that we can set in runtime. So from that, I'm gonna set an O-load. Basically, I'm just gonna copy the entire thing from a previous implementation, if you allow me. Okay, and we don't need to overwrite render anymore. Okay, and we can have this beautiful field here, which is a state machine input of double. So basically, we are locating factor, which is the same name we have here. Okay, and we are adding this input into this field and also setting right away a value of 0. So yeah, this should be building, I guess. Oh yeah, we can lose the paint green. And let me see if I'm missing something else. I guess no. So yeah, I thought I left it running, but somehow it closed it or lost the connection between Android Studio and the running thing. So that's why it's taking a while. Okay. The great things about live coding, it's always at least something goes wrong, I guess. I hope this is everything that goes wrong today. Right. I think we could go forward. Come on. Build macOS. Damn Apple. Okay, so we can go a little bit further. It's not wise, but let's go. I add this as a draggable, so I can make this component receives drag events. This is pure Flame stuff right now. But before that, draggable is also imported by material. So this is a good thing about developing a Flame game. So I would split Flutter codes and Flame codes into different places because of things like this, of name clashes like this. So I can hide draggable here. And I guess we are good. And we also have to make the game has draggable components. Draggable. Good. This should be running somewhere. Oops, yeah, it's running here. Woohoo, we already have it. Nice. Oh yeah, god damn it. We should make this a little bit bigger. Position, size, let's make this really wide. Oops. 636. Oh yeah. I changed the wrong dimension, I guess. Let's restart. Yeah, that was not everything that was going wrong. Oopsie doopsie. Got some keyboard errors. Weird, I'm not using keyboard. Good, yes, we have a split kind of animation, so I'm just going to keep this a little bit cut it off. I guess I could save again the file from this change. Yeah, I guess that's what I should do. downloads for backup and for our newest runtime. So this will give a RIV file for you. That is the thing that's supposed to be in your assets folder or somewhere that you're gonna put on assets, basically. So here we go. Downloads. Let me bring it to the project. Good. It's indexing and should try again. Yeah, I guess I will stick with this cut it off animation. I think this is a previous file. That's why there's a little bit of a mismatch of sizes between the ones that were previously set. So basically, we have a size for the component, but a size also for the artboard. So yeah, a little bit weird, but let's keep it like it, and bear with me. Live code things sometimes doesn't go as planned. So basically, we can also add, since we have a draggable thing, let's change the state machine from a user inserted input. So basically, when the user will drag, we will change the input. So what we are doing in this code, let me import this. So what's happening here? We are saving the input in this variable that we can check the nullability. So if it's null, we don't do anything and just keep on going. And when the user updates the drag, we get a delta. So this is basically what how many pixels the user dragged in a drag event. So this is fired every time the user drags. So lots of events like this one is fired. And we have lots of deltas. So I amortize this amount to a certain degree, and also direction. Clamp this to 0 and 100, and then apply it to the input. So I hope at least this works. And let's go. It's updating. Yes, at least this is working. Bear with me. I think this should be it, basically. Okay, size. I'm gonna try to fix this size thing. It's quite weird. I think it's something that I changed it like in the last seconds, basically, before the presentation. That's very wise. Never do that, kids, on your at home. And I guess that's it. 41. Yep, yeah, I'm doing something wrong here. But yes, that's what we have for an integration. So you basically have that pool coming from a drag screen. So I'm dragging right now with the mouse, and there we have it, basically. And just by curiosity, this is a part that I did for Rive for something that I had created on Flare, which is this one. This is the Flare version. This is not Rive. And basically, in the future, we will have a game that the user can rotate, basically, the angle, and also control the pull factor. Again, it's quite slow, but okay. And yeah, we have lots of other cool stuff in this little thing. So I still have to port to Rive and then work on Flame to it. So yeah, that's basically what we have for today. And check out the package Flame Rive, and also this example is open source. And yeah, that's it. Thanks a lot. Eric.
Awesome. Really cool to see Riven working with Flame in action. Uh, do you have any questions, folks? I think you have some minutes for questions. I think you have one already. So someone asked how many FPS. So did you manage to do some tests about performance and get a
I
feeling about
didn't
that?
see any lag. I didn't see any lag. I am at an 100 hertz monitor, so basically 100 frames per second, or whatever your hardware can handle. This is not expensive. This is not expensive operation. It's a basic vector painting, so we don't expect to have a lag here. Just only if you do a very expensive calculation stuff. But the secret is you have to know where to load your assets. So here we have this method on load that basically loads everything. But from a user standpoint, when we have everything loading and there's nothing in the screen whilst this is happening, uh, can be a little bit cumbersome. So remember, on games, it's really cool to have loading screens. It's very acceptable to have loading screens. So if you have lots of assets and you have to load before a phase or before a scenario, basically, you can uh, either use isolates or something like that. I don't know, or just reserve a loading screen for this. So yeah, everything once everything is loaded into memory, uh, painting should not be a problem in performance, basically.
Awesome. So just to be clear, this is already published, so people can just start using right away.
Yes, it's already on pub.
Awesome. That's super good news. We have another question. Let me show it to you. If the wire was released, it would have be a separate component, right? Then link it to the archboard to follow the movement.
Yeah. Yes. Basically, let me illustrate here what I was planning for this. So let's go for the Rive implementation. We have another counterpoint here, which is for the distance of the arrow from the hand, basically. And that was planning to do is once this reaches this position, we can hide this error and put a flame component there that will respect things like physics, basically. So in this frame, we would swap this two for swap this thing for a sprite component or something like that, and then use physics, custom physics to do the arrow kind of trajectory.
Awesome. Super cool. I think we are out of time. So thank you very much, Hannah, for the awesome presentation. I can't wait to see what people create with Flame and Rive together.
Yeah, thanks a lot for having me.
Always a pleasure. All right, so for the next part, I'm gonna do a very quick presentation for the final moments of FlameCon, where I'm gonna show some news from other work that has been done since our last event. So let me just grab my presentation, just a minute. All right, so that took a while, but here we go. So, all right, I will talk a little bit about all the news that we got from the previous FlameCon to the current state of Flame. So this is a very exciting moment for Flame. You did a lot of work. So I hope you all enjoy all the good news that we have for this presentation. So first of all, it's important to mention that we did many bug fixes. So Flame should be now on a way more stable state than it was on the previous one. So hopefully we got, I think, all of the bug fixes, hopefully. And we can now focus on making it more stable and hoping to try for a full blow V1 release. Also, important news, we spent some good time adding tests to Flame. So this is also in line with our request to make the framework more stable. And so we add from the previous version 23 new test files, and also we now have more than 60% test coverage of our code base. Some giant leaps that's worth mention from the previous version. So a big change now is that camera uses matrices for transformations. So this doesn't change much for the end user, so the APIs are pretty much the same, but this now means that we have way better performance now. So this is super cool, and a big shout out for the GitHub user ST Pasha with all the contributions that made this possible. We also have introduced the paint effects. These are pretty much like the previous, the current effects that we already had on Flame that basically change position and dimensions, but this is focused on the painting of the component. So far we have introduced the opacity effect and the color effect. We have also done a flowball refactor on the keyboard input system of Flame. So on the previous versions, we had some annoying bugs where we hear that bell sound when we hit many keys, and this should be done. We have complete refactor using better APIs that Flurry provided us. So this is also in line with your goal to support, to give you more support for desktop and web. So this is some awesome news too. This is probably the biggest refactor that we did. So we basically redid the Flame component system. For the end user, it should be pretty similar to what we had before, but internally it's a completely different system. So it's now way more powerful and way more flexible for us to add new components, to add new systems, and things like that. And some remarkable in-betweens that we also done. We did a refactor on our widgets. So currently we have like the sprite widget, the sprite animation widget, and a few other more. And now these widgets are more in like the Flare style of using widgets. So it should be way more easier now for people to use those widgets that we provide. We have added the sprite group component. This is pretty much like the sprite animation group component that we already had, but we are liking the sprite counterpart from it, so that was introduced on the latest version. And now the Particles API uses Vector2. This part of Flame, the Vectors API, was the only thing that was still not following the standards of Flame position system that uses Vector2. So we are able to refactor that, and now all the parts of Flame are using Vector2, and we are able to follow this standard. Another huge news is that we now have a new site for the docs, for the documentation of Flame. And this is another shout out to the GitHub user ST Pasha. He made this possible with his contributions. And this is very cool because now, from now on, we keep a history of all the versions of Flame in docs. So if you are using a previous version from Flame, you will have the available documentation on it as well the latest and all of them. We are also working on new tutorials. This is just a sneak peek of the tutorials that we're implementing. They are not ready yet, but they should be at least a first version deployed on the next following weeks. All right, so we also have some news about our bridge packages and the highlights. We have recently released a Flame block component. This is still very experimental, you can already start using it, and it brings Flutterblock and Flame together. So you have some alternatives if you want to share state between your game and a block. This is very useful when you use a lot of widgets in your game, so it makes easy for you to share the states between your game and the widgets that are concerned in your game. We also add a new Flame test package. This is also in line with your quest to make Flame more stable with more tests. So we are using this internally in Flame to test our own code base, but this is also available as a package. So anyone that wants to add unit tests on your game, this is available for you. You can start to use. At this point, we have two helpers. So the Flame test is for when you want to test your game outside the Flutter widget environment. And the Flutter widget test is the same Flame test, but now it's running on the Flutter widget environment. So you can do assertions to find favorites and things like that. This is a summary of all our bridge packages. So basically, at this point, we have all the bridge packages done and supporting Vue 1. All of them supporting Vue 1. They all have a sound no safety. We're missing a couple of them. We're still missing sound no safety. So all these should be ready for use now. And on the previous event, we talked a little bit about FlamePad. We show a little sneak peek about it, and now it is released and published at this URL. So if you go to pad.flame-engine.org, you will be able to test your Flame code live online. Just remember, for people who missed the previous call, this is basically a fork from Dartpad, which has Flame built in, so people can test their Flame games online. This is still maybe still unstable. We are making some tweaks, but we encourage the community to start testing. If they see any bugs, let us know, and hope you can make this more stable in the following weeks. And finally, the whole already does, right? So let's talk a little bit about our roadmap. So this is the state of our roadmap. So right now we are freezing features. So we don't plan on any new features unless they are like small things and additions, meaning that we are not accepting any more breaking changes at this point. We are hoping to release candidate 16 in the next on the following week. This version will include basically some minor bug fixes and some minor small features. And then we hope to have some weeks to gather feedback from the community to see how the API design from Vue 1 is, if there are any bugs. So hopefully we can get some help from the community testing Flame and reporting if there's any bug or any feedback. And given the feedback, given the bugs, we will probably release a few more versions in between. And we are hoping to release Vue 1 by mid-November. This is an estimate, of course, depending on how things go, we may delay, but how the roadmap is looking so far, it seems very much like that we'll be able to do this release by mid-November. And speaking about community feedback, we have some awesome news to share with you all today. We are doing the first Flame Game Jam by the end of this month. This event will be a way for us to bring the community together. And also we are hoping that with this event, people will do games with Flame and people will give us feedback about our current API, our current designs, and possible bugs, and help us make Vue 1 more ready for release. We will have prizes for the 3 first places. So there's also that if people join. And the event will be sponsored by our good friend at Very Good Ventures. We will have more info in the next days. We will assemble all the page, all the subscription for the event. And so stay tuned for our Twitter. We will release information about the event very soon there. And that's it. Any questions? Let's use this time for some questions. Okay, so is using Bonfire Online in the game jam? Sure. I mean, I'm not sure if Bonfire is already supporting the latest Flame. We require that the games on the gen use the latest Flame version so we can get feedback on the latest version. But hopefully, Rafa will be able to do that, and we can also help to make this Bonfire ready for the latest Flame version by the time of the gen. All right, so let me bring everybody to the call for a moment. Awesome. So if everybody has any question, anyone, we have the whole team here and our good friends from the Optic Games.
Almost the whole team.
Yeah, all the team available, I meant, sorry. We have another question. Is there a place where you can place feedbacks like OpenTix or something? I you mentioned about Flame, so on GitHub, yes, we can. We have issues, of course, for issues, and we have also discussions enabled on our repository. So any discussion,
You can always join our Discord.
Exactly. I believe this is a question. So the gem can only use the 1.1 version? Yes, we hope we will require that to use the latest release candidate because that way we can gather feedback for our version so we can work towards the full-blown release.
Yeah, the game jam is like an end user test for us.
And also, of course, prizes. Do you know which prizes are?
Yes, I was going to announce that later, but it will be cash prizes and it will be, let me get the prizes right here because I'm getting old and my memory don't serve me so well. We'll be having the first place $60 prize, the second place $30 prize, and the third $10 prize. So it's a way for us to say thanks for helping us getting feedback for the version.
Yeah, and if you live in Stockholm or in Datuba or Toronto or anywhere there is someone from the Flame team, physically, you will win a hug as well. A physical hug. That's it.
A physical hug.
Yeah.
Physical.
Yeah.
Okay.
If that's something you want.
All right. I don't think you have any more questions, so I'm gonna close the event. Thank you so much, Christian, Alex, for the presentation, Renan too. And that's it. If you guys want to say any last thing, feel free. You have a few minutes.
Thank you so much for having us. It was really fun. It is really, really fun to engage with people live, let's say. It's also the first time for me. So I wish luck to this event, to see it in the future as well, and to meet all of you again.
Yeah, same for me. It was really great, and it was a nice opportunity to show our project. And I think we also took some other things with us. The Rive things actually looks very promising because there's some new things on the horizon for us too. So maybe Rive is a good opportunity to look into. And a game jam, yeah, maybe. Why not?
Maybe.
Orbit Lite, like a light version.
Orbit Lite. Maybe reuse some of the components. I mean, as long as it uses the release candidate version 1, I think it's fine, no?
Yeah.
Orbit Rive.
Orbit Rive.
Recreate the whole Orbit game using Rive. Dynamically generating Rive components might be a bit too much for a game jam, but
Yeah.
But yeah, it's definitely interesting, and for sure we stick around.
Awesome.
Awesome. We're looking forward for your entry to the jam. All right, folks. So that's it for us today. Thank you, everybody, and hope to see you all on the next event.
Bye.
Bye bye, guys.